Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kalilinux. So in the previous tutorial, we saw how we could actually go ahead and use the Metasploit to our use, and it was also included and embedded in with the Metasploit as well. So in this tutorial, I'll be teaching you in deep about the Metasploit. So I'll just go ahead and start the MSF console to start with, and I'll go ahead and delete the previous payload that I created. It can take a bit of time to start. So this is how the MSF console looks like, an image of a cow, and yes, but we won't be I just opened this because if I won't be teaching you the MSF console through this prompt, so I will be teaching you in something different. But if you're wondering that why I actually opened this specific console, the reason for that is because if I open something else, then you might be wondering, and if you already have a bit of information about MSF console, then you might be thinking that MSF console is this thing and I'm teaching you something else. No, I'm teaching you what exactly MSF console is and how we could actually use that in depth. So that's the reason I wanted to teach you that this is how we can go ahead and access the MSF console. But there would be a more powerful command line interface to go ahead and access this framework, and that would be through MSF CLI. So I'll just go ahead and type MSF CLI. That is, okay, it's deprecated, I believe. So I'll just go ahead and use the MSF console itself. Perfect, never mind. So note that when you're using MSF console, variables are assigned using the equal to operator, and that all options are case sensitive. So you need to make sure that whatever you're actually trying to execute makes sense, or it is already there in the system, because it works through Ruby command line. That's why. So if you do have to, if you need help, or even if you have a single spelling mistake, then it won't work. But you can still use the tab completion method to go ahead and complete your statements so that you could execute them in a proper way. So to start with, let's just start. So okay, perfect. So you can just go ahead and type exploit and it will show you. Okay, so I'll just go ahead and type MSF console and I can just type exploit. I believe this was removed as well. Exploit slash multi. Let me just check if I could go ahead and so then I can just type exploit slash multi slash samba, and samba is for our own Linux distribution. And you can type, since I don't have any Linux, I won't be executing this now because I have only a Windows distribution over here which I could actually go ahead and hack. So, and I can just type script. So MSF console provides a powerful command line interface to the framework, and it allows us to easily add Metasploit exploits into any scripts that we may create. So I will use the equal to operator and it would be my rhost. So I'll just go ahead and select something random since I would not be actually accessing thing, and then I'll have to use the payload and make sure that it's case sensitive. So you type in the proper thing and cmd slash unix slash reverse and lhost equals to 172.16.193.63 space e. Perfect. So if you are not entirely sure about what options belong to the particular module, you can append the letter O in the end over here, right, exactly, so that it will exactly guess what you're actually trying to say. And it's own auto zero, just make sure that you enter the proper thing. So to display the available payloads for the current module, append letter P in the end instead of O, and you will exactly see all the available modules. So the benefits of MS Console interface would be that it supports launching of exploits and auxiliary modules. It is useful for specific tasks, good for learning, convenient to use when testing or developing a new exploit. It's even a good tool for off exploitation or one-off exploitation. It's very excellent if you know exactly which exploits and options you need, and it's very wonderful for the use in scripts and basic automation. But the only real drawback is that it is not supported quite as well, and it can only handle one shell at a time, making it rather impractical for client-side attacks, and it doesn't support any of the advanced automation features of the MSF console. That's why we don't use the MSF CLI as of now. So now I'll be coming back to the most important part, that is the MSF console that we have over here. So MSF console is probably the most popular interface to the Metasploit framework. So before I proceed, I'll just type MSF console that we saw over here previously, which has replaced the MSF CLI. Let's see what happens. Okay, so these things have been missing, so let's check X and what happens. Perfect. So as you can see, the MSF CLI has been deprecated and it was removed permanently, so we cannot go ahead and use that any further. We'll only have to use or work with the MSF console, and we would actually won't need the MSF CLI. So the MSF console is probably the most popular interface to the Metasploit framework. It provides an all-in-one centralized console and allows you to efficiently access to virtually all of the options available in the MSF. MSF console may seem intimidating at first, but once you learn the syntax of the commands, you will learn to appreciate the power of utilizing this interface. So benefits of using MSF console is that it is the only supported way to access most features within Metasploit. It provides a console-based interface to the framework. It contains most features and is the most stable MSF interface. It supports full line reading, tabbing and command completion. Execution of external commands is also possible in MSF console. Let me show you something. Let me check if I have my net access over here, if I have the NAT perfectly. I believe so. Okay, so I have my net active. So I'll just go ahead and check ping www.google. Oh no, I don't even need www.google.com. Let's see if we get something. Perfect. I'll just type Control Z and I'll just go back to the MSF console. Perfect. So as you can see, I can still go ahead and use the external commands inside the MSF console. And the MSF console is launched by simply running the MSF console from the command line as I showed you. And it is located in the user share Metasploit framework MSF console directory. You can pass -h to MSF console to see the other usages or usage options available to you. So while the time this starts, I'll go ahead and show you how exactly it looks like. I hope it should not go ahead and start the MSF console again. Perfect. So as you can see, we have different environment options, migration, no database, YAML path, and file, and lots of other things. So you can also go ahead and specify a directory containing additional database migration by typing the -e, or you can specify the database environment to load the YAML environment by typing -v and something more. So sorry, -v is for the version show. So in this way you can go ahead and access different kinds of things with the Metasploit MSF console terminal. The MSF console is designed to be fast and to use, and one of the features that helps this goal is tab completion. With the wide array of modules available, it can be difficult to remember the exact name and path of the particular module you wish to make sure use of. So as with the most other shells, entering what you know and then pressing tab will present you with a list of options available, whether you know it or not, and it will auto-complete the string if there's only one option. So tab completion depends on the Ruby readline extension, that's RRL, and nearly every command in the console supports tab completion. So I'll show you one example. You can just type use exploit, and as you can see, I just typed, if I can just type X and I can just hit tab, then there is only one thing that starts with EX, that's exploit. I can type W and it will select Windows because that is the only one, and I can select D, then you will see we have DCE or something like that. So I'll just hit enter. I don't know whether DCE is still there. Okay, I believe we have a 0, so I'll just hit enter. Okay, so we have all of these MSF0. Let's go ahead and select the DCOM module. So I'll just type _02 MSF03. Okay, I messed up a bit. Perfect. I'll hit enter. Perfect. So I'll just go ahead and type use net API. Let's see if that works. I probably think it won't because I already selected this specific term. Yep, it won't work properly. Yep. So I'll just go ahead and go back and I'll type use net and I'll hit tab. Okay, I believe use net API won't work. Let's see. I believe it should be period asterisk net API. Yep. Yep, it won't work. Perfect. So and then we can go ahead and you set the set lhost. So let's check if cannot log level. So I'll just go ahead and type lhost. So it won't work because it does not have the lhost as of now. Then we can go ahead and set the target, set the payload, and different other things. We can also go ahead and use the SMB method. So I'll just type use exploit / windows / SMB. Okay, I believe. Okay. So I'll just type use SMB / MS. Let's see if that works. So we have all of these things and we'll be selecting this one 03. Perfect. Net API. Perfect. So the MSF console is most commonly used interface in Metasploit, and making yourself familiar with this MSF console command will give you throughout this course and give you a strong foundation for working in Metasploit in general. So that is it for this tutorial. In the next tutorial, I'll be teaching you more about the MSF console core commands and how we can go ahead and work with them. Hey guys, and welcome to the next tutorial of ethical hacking and penetration testing via Kalilinux. So in this tutorial, we will be taking a deep look in Metasploit. So in the previous tutorials, I taught you exactly what Metapredator are and how Metasploit works and why MSF CLI was deprecated and MSF console was used instead for each and every other thing. So MSF console is most commonly used interface in Metasploit, just to give you a brief introduction about my previous tutorial, and it has a very strong foundation for working with Metasploit in general. So let's start with the MSF console core commands and let's gather what information that we can get. So the first thing that I would like to teach you would be the back command, so that in case you are stuck anywhere, then you can, and if you want to go back, you can just type the back and it will take you back exactly where you were. So once you have finished working in the particular module, or if you selected the wrong module by mistake, you can issue the back command to move out of the current context. This, however, is not required. Just as you can in commercial routers, you can switch modules from within the other modules. As a reminder, variables will only carry over if they are set gradually. And after that we have the check command. So there are not many exploits that support it, but there is also a check option that will check to see if a target is vulnerable to a particular exploit instead of actually exploiting it. So I cannot go and run that right now because I have not yet executed any kind of payload, but we'll see that later on. After that we have the color option, so you can enable or disable if the output you can get through the MSF console which will contain color. So I'll just type color and let's see color. Let me just check if I have never actually used it. Let's see, color true. Okay, let me check. Okay, I'll just go ahead and select it to false. And what is the other thing? Auto. Perfect. I'll set it to auto. So you can enable and disable this through the output through the MSF console that contains color. So after that we have the connect, and connect is a miniature netcat clone which is built into the MSF console. It supports SSL, proxies, pivoting, file sendings, and etc. So by issuing the connect command with an IP address and port number, you can connect to a remote host from within MSF console, the same as you would with the netcat or telnet. So I can just go ahead and type connect, and I can type this computer's IP address. Let me check exactly what it was. Okay, I need to run it as administrator, I believe. Okay, 192.168.236.131. So I'll just try 192.168.236.131, I believe, right? Perfect, 131. So yep, so I need to go and specify the source port and the source address. I have already provided that, so I can just type -s. This is the source address. Port would be -p443, and okay, specify a host and port. I should be able to connect it without even specifying this. Let me check. Okay, perfect. This is how it works. So I'll just go ahead and cancel this because I don't want to actually go ahead and connect it to that machine, but this is how it looks like. You can see all the additional options by typing connect-h. After that, we have the edit command. The edit command will edit the current module with visual or a text editor, and by default this will be open in the current module, that is vim. After that, we have the MSF exploits, and the exit command will simply exit the MSF console. So the info command will provide detailed information about a particular module, including all options, targets, and other information. Be sure to read always the module description prior using it, as it may have undesired side effects as well. The info command also provides the information such as the author and licensing information, vulnerability references such as CVE or BID, etc. Any payload restrictions the module may have, such as, I'll just go ahead and show you, info, and I can just type exploit Windows SMB / and let's say MS09 function index. Perfect, I'll hit enter. As you can see, these are the references, and it will give you the detailed information about your exploit. Okay, where did it go? Perfect. So these are the references. Okay, where did I? Okay, perfect. So this is a negotiate process ID function table. It's good. It was disclosed in 2009. That means it's quite old, but still Windows is not anywhere new, so it will straight away go ahead and work. It will work in Vista, Service Pack 1 and Service Pack 2. That means it will also work in Windows 7. We have the R host, R port, and these are the ports. So you can just go ahead and check that into detail. So after that, we have the IRB. So running the IRB command will drop you into a live Ruby interpreter shell where you can issue commands and create Metasploit scripts on the fly. This feature is very useful for understanding the internals of the framework. So you can just go and type IRB and it will open the interactive Ruby shell. I can just type Control-C, or let me check back. Okay, okay, perfect. Perfect. After that, we have the jobs module. So jobs are modules that are running in the background. The jobs command provides the ability to list and terminate jobs. So you can get more information by typing jobs-h. So we have the kill command, which I taught you previously, and the kill command will kill any jobs when supplied with the job ID, that is kill 1234, and 1234 is the job ID. After that, we have the load command. That the load command loads a plugin from Metasploit's plugin directory. Arguments are passed as key equals to value on the shell, and let's say, for example, let the Metasploit start and I'll show you. I can go and load the pcap log if I have. So let me check if I have my previous session's pcap log available. Okay, so I'll just go and type load pcap log. Perfect, and I'll hit enter. Let's see what we get. As you can see, I have successfully loaded the plugin by using the load command. After that, we have the load path. So the load path command will load a third part module tree for the path, so you can point Metasploit to your zero-day exploits, encoders, or payloads. So I can just type load path, and I can just type, let's say, /home, and I can /secret, or I can anything modules, something like that, where these is my final folder and these are the location where it is exactly. As of now, I don't have anything, so I won't be loading any specific path. After that, I also have the unload module, and conveniently the unload command unloads a previously loaded plugin and removes any extended command. So I'll just type unload pcap log. Perfect. After that, we have the resource command. The resource command runs resource files that can be loaded through MSF console. Some attacks such as Metasploit, they use resource files to run a set of commands in karma.rc file to create an attack. Later on, I'll discuss how exactly outside of Metasploit that can be useful, but I won't be actually running that. So I'll just go ahead and show you exactly resource Karma. I believe that was again removed. Yep, Karma was removed. So it was very buggy actually previous since a long time. So I believe they have removed that. Then we have the batch files, and batch files can greatly speed up testing and development times, as well as allow the user to automate many different tasks. Besides storing a batch file from within MSF console, they can also be parsed at startup using the -r flag. The simple example creates a batch file to display the Metasploit version at startup. So you can just type over here something like echo version, and you can just type version period rc. As of now I don't have the rc module loaded, but you can just go ahead and type that, or you can also type msf console -r version period rc. So through this you can go ahead and see the version of the MSF console that you are using. After that we have the route command. The route command in Metasploit allows you to route sockets through a session or COM, providing basic pivoting capabilities. To add a route, you pass the target subnet and the network mask followed by the session number. That's let's say for example you can just go ahead and type route-h and it will give you the details about whether to add, remove, get, flush or print the subnet mask and the communicator SID. After that we have the search command. So search can go ahead and search specific modules. Let's for example I will use search UAC, that's user account control. So it will search all the payloads related with the user account control of Windows, that's UAC. So you can use these commands to go ahead and bypass the user account control. Let's say if you want to run some scripts with, that need administrator access, then you can go ahead and first bypass the UAC command and then you can go ahead and access that. So in this way you can go ahead and do that. So search includes an extensive regular expression based search functionality. So if you have a general idea on what you're looking for, you can search it via the search option. And as you can see we have these, and this is the best one that I would normally use. And though it is not the latest one, but it is the most used exploit, because you can always go ahead and pass the user account control. So the search function will locate this string within the module names, descriptions, references, wherever it gets. So note that naming convention for Metasploit modules uses underscores versus hyphens. So if you go and type by mistake any kind of let's say a hyphen instead of underscore, it will not work. So let's say I'll just go and type search, and I'll just type, let's say, user map. User map. So you don't need to go ahead and type anything like a user map script, because it won't work. You need to use the underscore only, then it will work. So you can further define your searches by using the built-in keyword system. That is, you can just type help search and it will help you in different ways as to how we can go and say search specific things. And to search using a descriptive name, you can simply use the name keyword, and you can just type such as, if you want to search something in the name, you can type search name and you can type MySQL, and it will go and search anything and everything related to MySQL. So let it end. Perfect. So these are all the exploits related with the MySQL command. So that's how it looks like, and that would be it for this tutorial. In the next tutorial I'll be starting with the payloads and exploits, and that's it for the meterpreter prompt. There are multiple other commands related in the Metasploit, but I don't think that are as much necessary as these things, so I only taught the important parts. So but still you can go and check later on, and you can gather this information by searching the help command in the MSF console. So that's it for this tutorial. Next tutorial will be starting with the exploit and payloads chapter. Hey guys, and welcome to the next tutorial of ethical hacking and penetration testing via Kalilinux, the advanced distribution. So in this tutorial we will be taking an in-depth look into exploits and payloads. So let's go ahead and fire up our Kalilinux. So I'll just start my VMware. Okay. So all exploits in Metasploit framework will fall into two different categories. One is active and another one is passive. So active exploits will exploit a specific host. It will run until its completion, and then it will straight away exit. So today we'll be looking on to two in-depth types of things, that would be payloads and exploits. And after that, I will be giving you some good database description related to Metasploit. So let's have a look at that. Okay, so yeah, before I proceed, there are brute force modules that will exit when a shell opens from the victim, and module execution stops if an error is encountered. So you can force an active module to the background by passing -j to the exploit command, such as exploit-j. So I'll just go ahead and so you can just go ahead and type exploit-j, and you can go ahead and use that exploit. Or if you're in MSF console, let me just go ahead and open the MSF console. I will be using the Windows SMB psexec exploit, and I'll be showing you how exactly these two differ. That's active and passive failed exploits. By the time it starts, I'll just go ahead and also start another terminal. So now over here I'll be using the SMB psexec exploit. So I'll just go ahead and type use exploit, and I'll go ahead and use it for Windows SMB slash p, let me check, psexec exploit, and I'll hit enter. So it has accepted the psexec. I'll just go ahead and type set our host to my remote computer, that would be 192.168.236.130. This is my own IP address which I have received from over here. So yep, and I'll just go and hit enter. After that, I'll just go ahead and type, as you can see, we have the R host set up over here. After that, I'll go ahead and set the payload option, and I'll go ahead and I'll just go ahead and use the Windows one, Windows /shell/ and I'll use the reverse TCP, and I'll hit enter. So payload is also set up right now. That's the Windows shell reverse TCP. After that, now I will go ahead and select the local host. So I'll just go ahead and type set lhost, and I'll just go ahead and start up my Windows 7 as well. This is not actually a good idea, because most of the time if your firewall is open, even if the normal Windows Defender is open, it will not allow you to go ahead and exploit that particular system. So most of the time an active exploit is far better than just a passive exploit. But still, there are sometimes people using Windows XP in many of the organizations, and that's the reason I am teaching you that. And Windows XP is extremely vulnerable to this specific exploit. So I'll just go ahead and open my command prompt. Okay, so my IP address is 192.168.236.131. So I'll just type, and I'll just go ahead and set it to 1. Perfect. Now I'll hit enter. So I have the remote host set up, the payload, and the local host set up. Next thing I need to do is to go ahead and set the local port. So just type select L port to, let's say, for 4444 for example. You can choose anything, it's not anything like SN specific. And I'll be using the SMB user, so I'll just go ahead and select set SMB. Okay, so we have SMB, so I'll be using select SMB user, and I'll just go ahead and type victim. Okay, perfect. Set SMB user, and I'll go ahead and type I want to go ahead and select it to be the victim, so I'll just go ahead and type victim. Let me check. Okay, sorry, SMB user. Okay, so SMB user is the victim right now. So now I'll go ahead and select the S3CR3T exploit. So I'll just go ahead and select the same thing again, but over here I'll select S3CR3T. So that is secret, so it doesn't matter. If I had a different one, so I'll just go ahead and I'll do one thing. I'll just go ahead and use my own one, the one which I'm using right now. It's test user, so I'll just select test user, and I'll go ahead and select the password as smb pass, and my password is abc@123. And just remember that this password that I have used is extremely insecure. I have just used it for testing purposes, so I have used it. Now I'll just go ahead and type exploit. Okay, so as you can see, it tried to go ahead and connect to my remote server, but the connection refused. Okay, let me check if my connection is still active. Ping 192.68.236.131. Okay, the connection is active, so let us go ahead and try to exploit that once more. Test user abcd@123 exploit. Okay, so the reason for this is just ignore the part that it's giving over here that connection is refused. So what passive exploits does is that it waits for incoming host and then exploit them, so it won't work normally. What you need to do is that you need to make sure that the person over here is actually trying to go and access something from your system, and only when he does that kind of thing you will be able to access that. So passive exploits are always focused on clients such as web browsers, FTP clients, etc., because they need something to redirect something to them. They can also be used in conjunction with email exploits waiting for connections. And passive exploits report shells as they happen, as they can be enumerated by passing the -l to the sessions command. Passing -i will interact with the shell. So selecting an exploit in Metasploit adds exploit and check commands to the MSF console. So I'll just go back and I can just type, let's say, use exploit, and I can just type Windows SMB / and I'll just type MS09, and yep, perfect, and I'll hit enter. And inside over here I'll just go ahead and use exploit. Okay, sorry, I'll just go ahead and use the help. So as you can see over here, I'll just okay, and stop. So as you can see it over here, we have the different check option to go ahead and check if the target is vulnerable. So before I go ahead and proceed with that, I need to know whether what I'm doing will work. So after this, I'll just go ahead and type show. Let's see what happens. Okay, I believe the show should be in. Perfect. So this is what it does exactly. It's showing me now what will happen, and okay, perfect. So it's what is exactly is gathering all the information that that specific exploit can do, and it's showing me all of these things. So using an exploit also adds more options to the show command. So I can also type, let's say, like MSF exploit show targets, and it will also go ahead and show me targets if there are any. Okay, I believe show targets have, okay, let me check. Perfect, it should be lowercase l. So this exploit will work towards Windows Vista Service Pack 1, Service Pack 2, and the Server 2008. So now I need to go ahead and check whether there are any payloads related to that. So I can just go ahead and type show payloads and hit enter. And these are the payloads that are available for this kind of exploit. And these are showing exactly which one is encrypted, which one is not, and which one is the best used for our purposes. So after that, now we can go to also use the show advanced commands or show options and show evasion. So I'll just go ahead and type show options. It will show exactly what all I have set. If I have set something to the R port, it will go ahead and select that, else it will go ahead and select the default 445, and the R host would be my remote computer's address. So when I go ahead and set any of these things, it will show me that. So I'll just go ahead and show you that set R host 192. Okay, perfect. So let's see if what I get if I show options. Perfect. So the remote host is set. Now I'll just go ahead and use set R port, and I'll just type, let's say, 44. No, I'll just use 44, and I'll go ahead and type show options. and as you can see the R port has been changed. And there is one more method I can go ahead and type, that's show options, or show, no sorry, not show options, it's show advanced, and it will show me that how exactly will it work, what will be the verbose, and how many workspace will this module acquire to go and actually get the required number of port connections. So these are all the types of things that this can be done and this can be worked through. And the last thing would be to go and show evasion, that will show you exactly how what are the ways through which it can go ahead and evade some of the things, so that the person who is actually trying to, or the forensic investigator who is actually trying to gather information, he will not be able to gather any kind of thing. So yeah, that's it, and that is it for the exploits part. It's not much in detail, and exploits, there's not much to learn about exploits as well, because it's very easy to understand. So that's it for this tutorial, but I'll be continuing with the payloads stuff in the next tutorial, and just hang on for that. Hey guys, and welcome to the next tutorial of ethical hacking and penetration testing via Kalilinux. So in today's tutorial we will be learning about payloads. In the previous tutorial I have taught you about Metasploit, Metasploit and the exploits. So if you have not gone through that, then I would recommend you going through all of those tutorials, because else you will not understand what exactly payload is. So a payload in Metasploit refers to an exploit module. So there are different types of payload modules in Metasploit framework, such as singles, stagers and stages. These different types allow for a great deal of versatility, and it can be useful across numerous types of scenarios. Whether or not a payload is stage, it is represented by / in the payload name. So for example, let me just show you. I'll just go ahead and open the MSF console, and while the time it opens, I'll show you how exactly a payload would look like. So if I wanted a Windows, let's say bind TCP payload, then I'll just go ahead and use Windows/bind_TCP, something like that. It's a single payload with no stage, whereas Windows consists of a stager and a stage. So it might be a bit confusing to understand. So bind TCP is the stager, and if you want to go ahead and check the stage, then I can just go ahead and type shell_bind TCP. So shell over here is the stage, whereas bind TCP is the stager. So three things that I would be covering today in detail would be the singles, the stagers and the stages. So we have our MSF console open. So singles are payloads that are self-contained, and they're completely standalone. A single payload can be used, or it can be something as simple as a user, or adding a user to the target system, or running a calculator .exe file. After that we have stagers, and stagers set up a network connection between the attacker and the victim, and are designed to be small and reliable. It is difficult to always do both of these well, so the result is multiple similar stagers. Metasploit will use the best one when it can, and fall back to a less preferred one when it's not necessary, or when it's necessary. So Windows NX or NT version versus the no NX stager, they contain nothing. Reliability issues for the NX CPUs and DEP NX stagers are bigger. It's a virtual allocation, and default for now is NX plus Windows 7 compatible, so you don't need to worry about that. After that we have stages. So stages are payload components that are downloaded by stagers modules. The various payload stages provide advanced features with no size limit, such as Metasploit, or let's say VNC injection, or even the iPhone iPon shell. Payload stages automatically use middle stages. A single receive fail with large payloads. The single stager receives, or you can say as a single receive fails with large payloads. The stager receives the middle stager, and the middle stager then performs a full download, and it will go ahead and read, write, and can perform any kind of those tasks. So expanding on payload types in Metasploits. So I have briefly covered three main types, that is singles, stagers and stages. Metasploit contains many different types of payloads, each serving a unique role within the framework. So let's take a brief look at the various types of payloads available and get an idea of when each type should be used exactly. So let's start with the non-staged inline module. A single payload containing the exploit and full shell code for the selected task. Inline payloads are by design, you can say as it's by design more stable than their counterparts because they contain everything all in one. So however, some exploits will not support the resulting size of these payloads, but still some will. So these are how the inline non-staged look like. After that, we have the stager payloads, which work in conjunction with the stage payloads in order to perform a specific task. A stager establishes a communication channel between the attacker and the victim and reads in a stage payload to execute on the remote host Metasploit. And Metasploit is the short form of Meta Interpreter, which is an advanced multifaceted payload that operates via DLL injection. The Metasploit resides completely in the memory of the remote host and leaves no traces on the hard drive, making it exceptionally difficult to detect with conventional forensic techniques. Scripts and plugins can be loaded and unloaded dynamically as required, and Metasploit development is very strong and constantly evolving. So whenever you go ahead and try to run some kind of payload on your system and you execute a Metasploit into their shell, you don't need to worry about, because normally no one will actually be able to gather any kind of information whether you actually went ahead and gathered any kind of information or you actually hacked into that, because there are no traces left on the hard drive. It only works on the memory or the virtual memory, and you don't even need to worry about the RAM, cleaning the RAM, because it's not that hard after all. But still, there are chances that some people may try to find you out if they are checking that. But still, if they're checking what are the things that are actually consuming RAM. But still, that's again a totally different story, because payload or the Metasploit does not eat any kind of resources. It's a simple PowerShell or a command prompt kind of thing, which will hardly use like a few kilobytes. So you don't need to worry about any of these things, because normally any kind of application, if that's running, it will take probably a few MB, like 6-7 MB or up to more than even 100 MB. So you don't need to, so people will not actually go ahead and be able to understand it until and unless the person is actually far smart. After that, we have the PassiveX payload. So PassiveX is a payload that can help in circumventing restrictive outbound firewalls. It does this by using the ActiveX control to create a hidden instance of the Internet Explorer, and using the new ActiveX control, it will communicate with the attacker via HTTP requests and responses. So I'll just go ahead and explain this to you in detail. Let's say, for example, you have a firewall inbuilt, but somehow the person has gotten into your computer, but after he has sent you the exploit successfully passed on through your computer, but it is not able to go ahead and reach out, or it is not able to create a backend connection through the Metasploit to our own Kalilinux. So what the PassiveX will do is that it will create a fake Internet Explorer type of, let's say, networking prompt. And I'll just show you how exactly looks like. I'll just go ahead in the task manager. And I'll just go to the process. Okay, it won't take me. Okay, so this is how it will look like. So the firewall will probably think that okay, it's not a big deal because Internet Explorer is trying to gain access. So it will look something like it's actually something from the Internet Explorer that is trying to gain access, and the firewall will actually allow it. The reason being that it's going from inside to outside and not actually going to some random connection from some random application. So that's how strong it is. So after that, we have the NoNX module. So the NoNX is a short form for no execute bit, and it is a feature built into some CPUs to prevent code from executing into certain areas of memories. In Windows, NX is implemented as DEP, that is Data Execution Prevention, and the Metasploit NoNX payloads are designed to circumvent the DEP. So it's not a big deal to go ahead and bypass that as well. After NoNX, now you know what NoNX is. We have the ORD, that's ordinal payloads, and ordinal payloads are Windows stager. They are based, they're Windows stager based payloads which have distinct advantages and disadvantages. The advantages being such as it works on every flavor and language of Windows, such as XP, Windows NT, Windows 98, Windows 2000. It doesn't matter which until unless it is Windows and it works on DOS. And without the explicit definition of a return address. So they are extremely very tiny. However, two very specific disadvantages of ordinal payloads, make them not the difficult choice. The first thing that it relies on is the fact that WS2_32 period DLL is loaded into the process and it is being exploited before exploitation, which is not exactly happens every time. And the second thing being that it's a bit less stable than the other stages. So that's quite not a good thing for us hackers to go ahead and execute those kind of payload. But it works in every kind of thing in all types of Windows. So unless you have these two things running, it won't matter. So after that we have the IPv6 payloads, and the Metasploit IPv6 payloads, as the name indicates, are built into the function over IPv6 networks. So not much to know about all of these things, but these are the basics that you should know before going ahead and actually start using the payloads, because they can be quite harmful not only to the person whom you're trying to attack, but can be you, even if you're trying to go ahead and do some kind of mischief as well. So that would be it for this tutorial. In the next tutorial I'll be continuing with the reflective DLL injection and generating a payload for Metasploit. Welcome to the next tutorial of ethical hacking and penetration testing via Kalilinux. So in the previous tutorial I taught you about the different types of payloads, but I mentioned one thing, that there is one more thing, that is a reflective DLL injection. So reflective DLL injection is a technique whereby a stage payload is injected into a compromised host process and it is running in memory. It's never touching the host hard drive. The VNC and the Metasploit payloads, they both make use of the reflective DLL injection. We can read more about them from Stephen Fever, that is the creator of reflective DLL injection method. So I won't be getting much into that in deep, because I now have to go ahead and start as to how we are going to actually generate a payload for Metasploit. So now that we have an understanding of what payload is, payload types, and when to use them and how to use them, let's generate some payloads. So generating a payload is not that difficult in Metasploit unless you know exactly what you're doing. So during exploit development, you will most certainly need to generate shell code to use in your exploit. In Metasploit, payloads can be generated from within the MSF console. So when you use a certain payload, Metasploit adds the generate, pry, and reload commands. Generate will be the primary focus of this section in learning how to use Metasploit. So we'll just go ahead and use the payload. So I'll just type, okay, I'll just get back into my Kali. Let's type use, and I'll just type the payload, and I'll use the Windows one. So I'll just type Windows, and I'll be using the shell bind TCP that I showed you previously. And just make sure that this bind option is this is the underscore, and there are no hyphens over here. I'll hit enter. It has selected the Windows shell bind TCP, where shell over here is the stage, whereas the bind TCP is the stage. Oh, sorry, the bind TCP is the stage, whereas the shell is the stager. So now over here I'll just go ahead and type help to see what all things we have. So you can see I can go ahead and use these commands to communicate with the host. Yep, connect and all of these things. We have these database backend commands such as credentials, which I will be teaching you in the next tutorial. And finally we have the payload command to check, generate, pry, and reload. So now I would be going ahead and using the generate one. So I'll just since we need to generate a payload, so I'll just type generate space -h. So to generate shellcode without any options, simply execute the generate command. But over here I'm actually trying to show you exactly how we could actually generate a payload with some other understanding. So it would be forced encoding to go ahead and hide it from the antivirus or the AV. We have the list of characters to avoid so that the antivirus does not go ahead and detect us. Name of the encoder module, the output file, and if I just go ahead and type generate, it will just generate a simple without unencoded payload. So I'll just type generate, and as you can see, this is how the payload looks like. You may or you may not be able to understand exactly how it is, because this is just the script to go ahead and avoid or get, you can say, as get false permission from Windows to go ahead and access something from them. The real thing starts over here. That's how it looks like. So after that, of course, the odds of generating shellcode like this without any sort of tweaking are rather low. More often than not, bad characters and specific types of encoders will be depending upon the targeted machine. So this sample payload over here, it contains an almost universal bad character, that is the null byte, which is /x00. So if you look properly into this, you will surely go ahead and find this /x00 these stuff, and that's how the antivirus goes ahead and finds the actual culprit, that is our virus or the Trojan or whatever you want to call. Over here I'll be calling it payload. So granted, some exploits may use or it may allow them to use it, but not many. Let's generate the same shellcode, only this time we will instruct the Metasploit to remove this unwanted byte. So to accomplish this, I will issue the generate command followed by the B switch with accompanying bytes we wish to be disallowed during the generation process. So as you can see, I have this specific term over here which I will be using B to go ahead and avoid the list of characters. So I'll just type generate -B space and I'll type in inverted commas /x00 and I'll hit enter. So as you can see, this time there is no /x00 and it's quite a good encoded payload, whereas the last time you can see after the 82 we have /x00, whereas over here we don't have that. You can go ahead and search the whole file, you won't even find anything over there. So looking at this shellcode, it's easy to see compared to the previously generated bind shell. The null bytes have been successfully removed, thus giving us a null byte free payload. So we also see other significant differences as well due to the change we enforced during generation. One difference is the shellcode's total byte size. In our previous iteration, the size was 341 bytes. This new shellcode, however, is 27 bytes. So that's quite much of a difference that created with the help of null bytes payload. So I'll just go ahead and generate this. And this is normal one with the 341 bytes, and if I go and type this is the normal one with our 27 bytes. So it's quite good. So yeah, so during the generation, null bytes original intent or usefulness in code, it needed to be replaced or encoded in order to ensure once in memory our bind shell remains functional and it is not thrown out by the antivirus. Another significant change is added to the use of encoder. By default, Metasploit will select the best encoder to accomplish the task in hand. The encoder is responsible for removing unwanted characters, amongst other things, entered when it was used with the -B switch like I used. So I'll discuss the encoders in great detail later on. So while specifying bad characters, the framework will use the best encoder for the job. And the best over here is the into 32-bit, that's x86/Shikata Ganai. That, and you might be wondering that if I have heard about that before. Now I'll show you exactly where we have seen it. Let's select social engineering, and I'll just go ahead and use some random stuff. And these two, and over here as you can see we have the Shikata Ganai. So this is where we have heard it previously. So yeah, coming back to our point, the into 86 Shikata Nagai encoder, it was used only when the null byte was restricted during the code generation. So if I add a few more bad characters, a different encoder may be used to accomplish the same task. So let's add several more bytes to the list and see what happens. So I'll just type generate B/ and over here I'll just go ahead and change some of the things, such as /x44 /x67 /x66 /x, let's say. We'll also use some characters, and /x01 /xe0 /x44 /x67, and what else, let's say xa1, let's say for example, xa2 /xa3 /x75 /x4b. Perfect. So we'll be using these, and we will use a different encoder. So let's see what happens. All of these unwanted bytes were removed. Perfect. But the size over here is 350 bytes, whereas over here it was 355, and over here it was 328. So what is the difference? So we see a different encoder was used in order to successfully remove our unwanted bytes. Shikata Ganai was probably incapable of coding our payload using our restricted byte list, and FNSTENVMove on the other hand was able to accomplish the same thing. And as you can see, we have the FNSTENVMove which had encoded this. So having the ability to generate shellcode without use of certain characters is one of the greatest features offered by this framework. This doesn't mean it's limitless. If too many restricted bytes are given, no encoder may be set up for the task, at which the Metasploit will display something such as the payload generation has failed. Let's go ahead and try something like that. I'll use the same code with a bit of modification. 44, 67, 66, XFA, X01, XEO, 67 until 4XB, and let me just go ahead and change this a bit. I'll use XFF slash X0A slash, let's say, X0B slash X01, let's say slash, X01. After that, let's say XCC slash 6E slash X1E, and then we have slash X2E. We have, let's say, slash X26, and let's see what happens right now. As you can see, no encoders encoded the buffer successfully. So it's like removing too many letters from the alphabet and asking someone to write a full sentence. Sometimes it just can't be done. And if you have seen that in movies, that they can just go and type something and hack into something, that's how exactly this is. It does not work. In reality, at least not. You have to just sit inside in front of the computer and wait for something to happen. That's not going to happen. You have to actually try for that to happen. So using an encoder during a payload generation is not that difficult, but at the same time it's not that easy as well. So as mentioned previously, the framework will choose the best encoder possible when generating our payload. However, there are times when one needs to use a specific type, regardless of what Metasploit thinks. Imagine an exploit that will successfully execute a command, provided it contains only non-alphanumeric characters. The Shikata-Nagai encoder would not be appropriate in this case, as it uses pretty much every characters available to encode. So looking at the encoder list, I'll go ahead and show you something different, but that would be it for this tutorial. And in the next tutorial, I'll be going ahead and I'll be ending this payload tutorial by showing you how we could actually go ahead and use some different encoders to redo our bind shell payloads.